Okay, the second part of the question that's going to show up a bunch on the problems that you're being asked to do in Sapling, have to do with finding the absolute max and min values on a particular interval. So again, being that our graph looks something like this, where it went down forever and went up forever, there is no max, absolute max, and no absolute min. There's a relative max and a relative min, a local max they call it, or a local min, but there are no absolute max or mins. But in this situation, if we narrow it down to a specific interval, then the extreme value theorem said that if you're on a closed interval on a continuous function, then there's got to be a max and there's got to be a min, absolute max and absolute min. So we're going to check on the interval 0, 2 and verify what that sequence is. And let me just show you real quickly. The logic of it is really clear, but let me show you the steps that they give on the slideshow. So take a look at this with me. So steps for finding the absolute extreme values of a function. Given the function is continuous on that closed interval, and ours is between 0 and 2 is what we were talking about, locate all critical numbers in the open interval, so that means it's either going to be a top value, a hump like ours situation was, or a low value. So you find all the critical numbers and then evaluate at each critical number and the endpoints. And the biggest number will be the absolute max, and the smallest will be the absolute min. It's that straightforward. Find the critical numbers, evaluate the function at the critical numbers and at the endpoints, and see which one's the biggest and which one's the smallest. That's it. So let's do that. Let's do it now, and our situation right here. So we found all the critical numbers for that function, where we're 1 and 3. And on the interval 0 to 2, we've got critical numbers at 1 and 3. The 3 doesn't matter because it's not in the interval of concern. But, so we do have 0. We do need 0 as an endpoint, 2 as an endpoint, and 1 we found to be a critical number that's in the interval. So we need to check out, all we got to do is check out the endpoints, plug in the values, the endpoints, and the critical value. I put them in order just for sake of ease of sequence or whatever. And now it's just a matter of plugging the numbers in to calculate. Notice that this is the correct notation when you're plugging 0 in for x. This is not f of x when we plug 0 here. This is f of 0. You're plugging in 0, so it's got to be marked f of 0. So it turns out to be, you can see we can do this kind of quickly because every one of the x terms are going to be 0. So we've got 0 minus 0 plus 0 plus 5. So that equals 5. 1 is also pretty straightforward. Notice we're plugging it back into the original function and not the derivative function. We're wanting to find the actual value that's on the graph. That means it is in f of x, the original function. Let's plug in. So now the critical number we found was 1. Let's plug that in next. We get 1 cubed is 1. Minus 6 times 1 is minus 6. Times 1, we've got 9. And 5 is there, so that gives us what? 10, 15 minus 6 is 9. And then for f equals 2, there's going to be a little more complicated calculation in this situation. Let's plug in 2. We get 2 to the 3rd minus 6, 2 squared, plus 9 times 2, plus 5. And that gives us, let's get this out here, we get 8 minus 4 times 6 is minus 24. We've got plus 18 plus 5. So let's see, that gives us 26 minus 24 is 2 plus 5 is 7. So that's it. So of those 3 points that we were concerned about, the lowest value is 5. Therefore, that is the absolute minimum. 9 is the largest, therefore the absolute max is 9. So the absolute minimum occurs at 0 and is 5. Absolute max, equals 9 at x equals 1, and absolute min equals 5 at x equals 0. And so that's it. That's it, the situation. So it's follow those steps, do the work over the problems, and work through this. If you have trouble, go back over it and review it. Let me know, because we're going to be doing this a bunch, and you'll be doing it a lot more on some other types of problems that we're working with as well. Okay? Got any questions, let me know. Write them down. Get back with me. Talk to me soon. Bye.